There are two common test procedures for fuel injector testing. You can look at the injector voltage waveform. That's a form of testing, one of the two. You can look at the injector current waveform, and that's the other. In the photograph in the background, at the top, it's pointing to a voltage probe on the control side of the injector, and just for the sake of space, the low current amp probe is placed around the positive. It may be placed around the negative or the control side just as well. Now, voltage testing uses the ground, the control side. Current testing uses the B or the ground side. It really doesn't matter. What we're looking at here is on the left, you can see a drawing of a pin that is pushed down in beside the control side, and then your scope lead on that. And in the schematic there, we drew a box around the injector control as well as the positive. Connect the lab scope to the ground, the control side of the injector, for voltage testing. Now, fuel injector voltage is in the upper left. That's the waveform you would get. Amperage is in the upper right. And then the large picture in the lower right shows a two-channel scope. The top waveform is the current, and the bottom waveform there is the voltage. So let's look at the voltage waveform. When you look at it, start with battery voltage. It should be near battery voltage, within a half a volt of battery voltage. Now, if B plus isn't normal, test the fuse and the wiring to the injector. If you don't get a pattern at all, you want to check for B plus there, and if you don't have B plus going to an injector, once again you'll want to check the fuse and the wiring to the injector. If B plus isn't normal and the circuit is okay, then go to charging system test. You know, if that's at 11.1 or 10.9, maybe you have a charging system problem that you have to take care of. When you look at the ground, you're looking at that waveform. It was battery voltage. When the PCM grounds that injector to turn it on, that ground specification should be under 400 millivolts, 0.4 of a volt. The PCM supplies the ground for the injectors. You can see in the waveform in the top left, the ground part is supplied down here at the bottom right, and that's where the PCM turns the injector on. If the ground voltage is over 0.4 of a volt, check the wiring from the injector back to the PCM. If the wiring's good, you're going to have to go test the PCM and see if its drivers can control that injector. Now, after the PCM releases the injector, turns it off, there's going to be an inductive kick. Should be equal to all other injectors. Just compare them to all the other injectors on the vehicle, and it should be equal. And it must measure at least 35 volts. If it isn't, test the PCM's driver and B plus, or replace the injector. Now, once all the events of the injector being turned on and turned off are done, we should return back to battery voltage within a half a volt of B plus. Current testing is done during the time the injector is on. The injector current waveform testing is done with a low current probe around the positive or the negative side of the injector. You can see the pattern we get here, and this point where the current starts to rise is when the PCM grounded the injector or the injector is turned on. The hump somewhere in the center indicates the pindle opening, that the pindle inside the injector is actually moving. All the injectors should have a pindle opening about the same position in the waveform. If the opening is lower on the waveform, it indicates a weak closing spring in the injector, which may result in a rich condition, and you'll want to replace that injector. Opening higher on the waveform indicates a dirty or a sticking injector, which could result in a lean condition. Once again, you will try to clean it, and if you can't clean it, you'll have to replace it. Now, once you get your waveform up there, you want to compare peak amps to specifications. You can see our specs here are 1 to 1.2 amps. Higher amps are most likely caused by shorted injectors. Shorted injectors can affect other injectors on older gang-fired systems. We don't see many gang-fired systems anymore where one PCM driver fired multiple injectors. But if you had one shorted injector at that time, it could affect the other injectors on that gang. Now, this is an example of low injector current. It's lower than normal. The first thing you want to do is ensure that B+ is present to the injector. Bad grounds and PCM drivers are the most common reason for injectors with low current. You go test the PCM. You will now be returned to the test selection menu. Make a selection based on your test results.